So a system of linear equations is a collection of linear equations in whatever forms they come in, involving the same set of variables. So my example here, I've got two equations, negative 4x plus 3y equals negative 2, and I've got y equals x minus 1. So y equals x minus 1 is in what form? What form? What form? What form, Scott? Slope-intercept. All right, that means that this is in what form? You sure about that? Now, technically it's not. Why is it technically not in standard form? There's one problem here with this equation. Yes, ma'am. Yeah. X is negative. X is negative. It has to, standard form, the rule for standard form is that my A value has got to be positive. The rule for standard form is that my A value has got to be positive. Now, it was supposed to be in standard form, so it's all good. We're all gravy. All right, but technically, quote unquote, it's not exactly in standard form. But we're Gucci. Okay, for better sake, okay, it's in standard form. All right, so let's look at our first example. Which of the following equations best represents the situation below, and why? So our situation is that concert tickets cost $15. Wow, that's cheap. Concert tickets cost $15. So we're going to go see Little Baby. Okay, $15 to get in the gate. Only $9 if you got your student ID. Fantastic. Ticket sales total $4,500. Write and graph an equation that models this situation. All right, so tell me, Ishka, what does X represent? Sorry? I can't hear you, bud. What does 15 represent? Ticket cost. Okay, so ticket, not cost, but the tickets.
How many are the tickets?
So tickets sold. Tickets sold, right? So if we sell one ticket, we would plug in 1 for X. But if we sold 400 tickets, that's totally different. Right? We plug in 400 for X. Okay, so the X is the number of tickets sold. Now, Ishka, what you were saying is 15 goes with the X, because 15 is the what, Ishika? Starts with R, ends with 8 of change. Rate of change, exactly. So 15 times the number of tickets sold, or 9 if we're a student, times the number of tickets sold. Okay, so X is the number of tickets sold. That would be my input. Right? That's what I'm inputting into the equation. So then, Carmine, what is Y? What does Y represent? No. Concert tickets cost $15 for general admission, but $9 for the student ID. So those are associated with my input, because that depends on how many people are coming. Okay, so I can have one person come, or I can have 1,800 people come. Now the Y depends on who comes. So this is my input. The Y is my dependent variable. So what depends on the number of people coming? It's in the problem. Carmine, it's in the problem.
Oh, wait, what is it?
What is the Y? It's the same question that I asked you. What's the Y represent?
Ticket sales?
Yeah, total sales, ticket sales. So the total sales depends on how many tickets I sell, right? It's not the other way around. How much money I'm making depends on how many people are coming to the concert. Okay? If Little Baby's playing, I guarantee you that's going to get more money than if I was up there singing karaoke. Okay? 100%. Alright? So the total sales depends on how many people are attending. Now, if you want to get a good laugh, I'd probably go to my show over Little Baby. Okay, but that's just me. Okay, so now, question being, okay, of those three types of forms, okay, of those three equations, which one is the easiest to work with? Which one is the easiest to work with? Point-slope form, or slope-intercept form, or standard form? That depends on my problem. That depends on how many inputs I have and how my problem is set up. In this case, okay, I've got 15 rate of change times x. Okay, I've also got 9 rate of change times x. Okay, and that's going to equal my total sales. Okay, so I've got concert tickets costing $15, so I could write a equation for that. Total sales is equal to 15 times x. Okay, I've also got ticket sales, y, is equal to 9 times x. Okay, you've got two different selling points. You're selling adult tickets, general admission, and you're selling student tickets. Okay, and so what I would want to use is this equation right here. Now, this should be a plus sign, right? Because I'm going to add those two numbers together and get my total ticket sales of $4,500. So both of these total, which Carmine told me, total sales, 4,500, is equal to 15x and 9y. Okay, so yes. Okay, let's move it on. Second example. All right, we're getting swell. Okay, so Jim's going to choose between two gym memberships. Right, he's going to get his workout on. Okay, every day is chest day. So plan A, $50 monthly membership fee and a $10 per visit fee. Plan B, it costs $25 per month, but a one-time membership fee of, 25 monthly one-time membership fee and $15 per visit. Okay, so here we've got $10 per visit. Here we've got $15 per visit. Now, let me give you a hint. When you see the word per, okay, that is telling you that is the number that is going to be associated with your X. That's telling you that is your rate of change. That's going to be associated with your X. Per visit, that's telling you 15 times the number of times you go. Or $9 per ticket sold. So 9 times the number of tickets sold. 15 times the number of times you go to the gym. So when you see the word per, that's telling you that is your rate of change. That's going with your independent variable. So again, we're looking to denote our variables. What does X represent and what does Y represent? All right, so let's see. Noor, what does X represent? Yeah, how many times we go to the gym, right? So X represents the number of times we go to the gym. Okay, so again, that is my independent variable. We can go as many times as we want to, right? As long as we got enough money to support that. The Y value depends on how many times I go to the gym. What's the Y value, Nishat? Total what? Total cost or total amount paid. Same thing. Great. Independent, dependent. Let's go to our summary here at the bottom. How many rates, slopes there are? Okay, and is there a starting point? So if there is a one rate or one slope, we would use slope-intercept form. If there are two rates, let's use standard form. Right? So if we have two rate of change, like let's go back to our concert problem. Okay, we had $15 for general admission and we had $9 for student ID. Those are two different rates. So we have two different inputs. Standard form. That's the easiest one to work with. 15 times the total of general admission tickets plus $9 times the total student ID tickets, total cost. So standard form if we have two different inputs. If we have one input, just use slope-intercept form. Easy breezy, write your equation. Is there a total given? So if there is no total given, then obviously it's unknown. If it's unknown, we've got to use slope-intercept. If there is a total given, then we can use our standard form. In our standard form, C would represent your total. Okay, so I know that's a lot of words for something that you really already intuitively do, right? If we have a total, if we have our C value, all you're doing is you're telling me the number of general admission tickets sold plus the number of child tickets sold is equal to my total. You've got your total, plug it in standard form. Here, we don't have our total. It doesn't tell me what the total cost I'm paying. So I need to write that in slope-intercept form, right? $50 monthly membership fee, 50 times X plus 10. No, sorry. Yeah. Plus $10 per visit. Why? Okay, and now you're looking for your total cost. All right, put it to the back. Let's work on writing our systems. Writing our systems. Okay, again, a system is a set of linear equations. Multiple linear equations. Right? Okay, here we go. Miss Kitts works at a music store. Last week she sold 6 more than 3 times the number of CDs that she sold this week. Miss Kitts sold a total number of 110 CDs over the 2 weeks. Which system of equation can be used to find L, the number of CDs she sold last week, T, the number of CDs she sold this week. Now, if it's me, I'm always going to denote my variables. Right, so what does L mean? It tells me that L is the number of CDs she sold last week, L for last week. T is the number of CDs she sold this week, T for this week. So L, last week, she sold what? She sold 6 more than 3 times the number of CDs that she sold this week being T. So help me write that equation. 6 more than 3 times the number of CDs she sold this week. 3 times. So favor, how do I write 3 times the number of CDs this week? 3T. But she sold 6 more than that. Three T what? Plus 6. So last week she sold 6 more than 3 times the number of CDs she sold this week. All right, so there is your first equation. Now, again, we're reciting up a system of equations. A system of equations. So, Riven, help me out. What is my second equation equal to? Fantastic. How many CDs did she sell? She sold 110 total over the 2 weeks. How do I write that? Last week plus this week. Sorry, plus, holy smokes, that's a T. My fault. Last week plus this week, the number of CDs she sold last week plus the number of CDs she sold this week is equal to how many? 110. There it is. Bam. There's your system of equations. All we're doing today is we're setting these up. Tomorrow, guess what we're going to do? Solve them. So all we're doing today is we're setting up our system of equations. Okay, then tomorrow we will review what we learned in Algebra 1 over our methods on how to solve equations. Okay, questions on your notes for the greater good.